And we're back again with the second part of P6. We're going to now talk about factoring by grouping. Factoring by grouping is a method you generally want to use when you're dealing with polynomials that have 4 terms. Occasionally, textbooks might refer to a trinomial method we'll look at later as grouping as well. That's because it involves this. But the general method, factoring by grouping, needs to have 4 terms. The way you can recognize when factoring with grouping may be done is when you have coefficients in a certain ratio. For example, if you notice here, I have 2 and 6, 1 and 3, negative 2 and positive 6, negative 1 and 3. The second coefficient is always negative 3 times the first. If you have that kind of relationship, the same ratio between coefficients, factoring by grouping will work. The way grouping works is it's very similar to what we were doing with pulling out common factors. You just group your terms into sets of 2. So I group the first 2 and the second 2. It would be fine to group these 2 and these 2 as well, every other term. The only grouping that wouldn't work would be the outers and the inners. But we're grouping the first 2 and the last 2. And what you do is you just pull common factors out of each group. So from the first group, I have an x squared common. If I take out x squared, I will have 3x minus 1. And from the second group, I have a 2 common. So if I pull out a 2, I will have 3x minus 1. And now you might note a similarity to a problem we were doing in the last video. Now we have a common parentheses, so we can pull that out. And we've factored it completely. It's really not a big step up from pulling out common factors, factoring by grouping, but it's an elegant method in and of itself. Our second problem with factoring by grouping will probably just be our last problem. I don't usually do that many exercises with grouping. So we'll just do the same thing. Group the first 2 terms, group the second 2 terms. Pull out an x squared from the first 2. We'll have 2x plus 1. From the second 2 terms, I'm going to pull out a negative 3. If I pulled out a positive 3, I would have negative 2x minus 1, which you see has the right terms but the wrong signs. So to switch the signs, you'd pull out a negative 3 instead of a positive 3, and then we'll end up with 2x plus 1. We then have a common parentheses. Take that out, and we will be good. Our third method we'll be looking at is the set, or I guess I should say our third class of methods we'll be looking at is the set of trinomial methods. And these are specifically for factoring something in this form, where I have a x squared plus bx plus c. It also would apply if I had ax squared plus bxy plus c squared y squared. Sorry, not c squared, just c. But I usually just start with this form. It's no different if it has this form, though. You just have to remember to include y's as well. And we've multiplied out expressions and gotten similar forms to this. If you recall from the last section when we multiplied a couple of binomials, like 3x plus 1 times 2x plus 3. We ended up, I'm going to skip the middle step here, 9x plus 2x would be 11x plus 3. We ended up with a trinomial. And in fact, every trinomial we factor is going to be of this form, two binomials when we're done. The first problem we're going to look at for doing our trinomial methods is this exercise 17. And I'm going to do what's sometimes called grouping, but I call it the AC method. It's called that because you have a polynomial in ax squared plus bx plus c form, and you start off by multiplying the a times the c. Well, you can read off the a is 3 and the c is 5. So that's going to be 15. And what you need to do next is find a factoring pair of this 15 that adds to be the middle number. Well, since it's a positive 15, both the numbers in the factoring pair are going to have the same sign because they have to both be positive or both be negative. 3 and 5 do not add up to be 16, but 1 and 15 do. So that's the factoring pair I want, and they've got to add up to be negative 16, so I'm going to make it negative 1 and negative 15. Those still multiply to get positive 15, but they will add to get the negative 16 I want. And then you take those and split up the middle term. So we just end up with 3x squared unchanged minus 1x minus 15x plus 5. And yes, it would be fine to write the 15x first instead of the 1. It doesn't matter because the next step we're going to do is grouping, factoring by grouping. Because now we have 4 terms, and we know it will work with factoring by grouping if you found a pair here. If you didn't find a pair that worked with the polynomial, then this polynomial would be prime. It wouldn't factor. And that's what you'd say for your answer. So let's see here. I can pull out an x. That'll leave me with 3x minus 1. And I can pull out a negative 5. That'll leave me with 3x minus 1. And my final answer then will be 3x minus 1 times x minus 5. The other method, which I won't do that much, but it's still a valid method, is just trial and error. You know you're going to end up with two binomials multiplied times each other. So you just say, well, the only way I can get this first term is by multiplying the firsts in each binomial. So the only things that multiply to get 3 are 1 and 3. So one of these has to be 3x and the other has to be x. The only things that multiply to get the 5 have to be the last, are 1 and 5. So I just have to have a 1 or a 5 in each place. And you can just think about how large the multiplications are going to be if you're going to get the middle term. Because the middle term comes from multiplying the outers and the inners. So I have 16 there. I can think, well, if I multiply 3x times 5, I'll get 15. So that'll probably be pretty close. So then you'd want a 1 here and a 5 there. And then they both have to be negative. And you just check the outers, negative 15x, and the inners to make sure you get the correct middle term. Now, of course, you aren't necessarily be certain of your answer, so you should check it. And if you don't get it, like if I got the wrong number here instead of 15, maybe I got something else. Instead of 16, I should say. You got something else. Well, then I would try moving the 5 here and the 1 here. And if that didn't work, I would know that 1 and 5 would not work as the factoring pair. If you do end up with the right number but the wrong signs, then all you need to do is flip both of your signs in the factorization. So here is our correct answer in this problem. And let's do another one. This problem, I'm going to do it 2 ways. First, the long way. Full AC method, I would multiply 9 times 45, negative 45 I should say. And that's going to be a large number. Let's see. 10 times 45 would be 450. So take away 45 from that and I'd get 405. Because, yeah, 10 times a number, take away 1 of that number, you'll end up with 9 times that number. Yep. So I need a multiplication. Oh, I think I've already found it. I need a multiplication that makes negative 405 and adds to be negative 36. Well, luckily, it's the one we started with, 9 times negative 45, so I don't have to look at any of the others. There are quite a few. It's not hard to find more factors of 405 because you can just look at the numbers you have. See, 9 has 3's in it, so that means I know 3 is a factor. See, if I divide 3 out of 9, that leaves me with 3. So you just take the other 3 in 9 and multiply it into the other one. 3 times 45 would be 135. What else is in there? In 45, there's 5. Take 5 out of 45, that leaves 9. 9 times 9 is 81. Also in 45 is 2 more 3's because of the 9. So that means 27 is also in there. So take a 3 out of 45, you get 15. I think that's probably it. Did 9 times 45, 27 times, yeah, I think that's probably it. Oh, 1 and 405, of course. You don't need these, I'm just going through the process so you can see on a problem. The first one was the one we wanted. So we split up the middle term, 9x squared minus 45x plus 9x minus 45. Common in the first group would be a 9x, and we'll end up with x minus 5. From the second group is just a 9. You have x minus 5 again. So we end up with 9x plus 9 times x minus 5. And if you'll notice here, I'm not done, because in this factor, there's a common factor, a 9. If you pull that out, get x plus 1 times x minus 5. That's the final answer. Now there's an easier way to do this problem. Because I had a common factor at the end here, that indicates there was a common factor at the beginning. And indeed there was. That 9 was in every factor, every term, I should say, in the beginning of the problem. So you really should start off the problem by doing this. 9 times x squared minus 6x. No, that should be 4x. I'm sorry. Minus 5. And this is much easier to factor because you just do AC method. You have 1 times negative 5, which gets you negative 5. And those already add up to be negative 4, so if you split it up, x minus 5x plus 1x minus 5. Pull out an x from those first two, x minus 5 I already have what's in the parentheses in this second set of terms here, this second group. So I'm just going to leave it alone and treat it as if I divided it by 1. I pulled out a 1, because dividing by 1 isn't going to do anything. So now I've got x minus 5 times x plus 1. And don't forget to put that 9 that we pulled out at the beginning back on the front. It's always worthwhile to pull out common factors first if you can, even if it's not strictly necessary, as in this problem. It'll still often save you work. And in fact, this one can be done even quicker. So we'll do a third method. You can do a shortcut if the coefficient, the number in front, of the x squared is 1. If that's the case, you can jump straight from your factoring pair to the answer. Because look here, 1 and negative 5. X plus 1, x minus 5. Same signs, that's not a coincidence. That will always happen when there is a 1 in front of the x squared. So that's even another reason to pull out the 9 first, because it will save you a lot of time if you see the shortcut. Let's do a problem where we can use the shortcut at the beginning. You see here we have a 1 in front of the x squared. It's not that many factors of 15. 1 and 15, 3 and 5. And it is a negative 15, so they got to have opposite signs. With 3 and 5 have a difference of 2. So if they're going to add together to get 2, it would have to be a negative 3 and a positive 5. And I can just jump to the end then. X minus 3, x plus 5. You can check by multiplying out again. X squared minus 15 plus 5x minus 3x. And yeah, that's what we started with. So this is the correct factorization. Shortcut's really nice. And in fact, if you want to use the shortcut on the other types of problems, the ones that have something in front of the x squared, there is a way you can do that. It's called the slide and divide method. I'm not going to present it in this class, but if you want to look it up, just Google it. Slide and divide method factoring. Historically, several of my students have preferred it. Not all, but some. You're certainly welcome to use it. I think that's all the time we'll use for this video. So next time we'll come back and finish out the section. We'll talk about some factoring methods. We'll talk about the last factoring method, which is using some factoring formulas. I think that will finish the section for us. So I will see you in the last video of P6. Talk to you then.